All right. So I left you with these two questions and page 93. So we're going to do these two questions. Then on page 93, we'll whip through that. And then 94 and 95, I think. I can't remember because my computer's not working. I know. It's not like it's any different. Close window. Open window. Right. 93 I asked you to do already. And then 94 and 95, we're going to work on this block. And we're going to get that out of the way. And then we're going to move on to the next thing. The reason I do this is because this is so important to higher level math. I take a little bit of extra time with it. So let's fix this up. Cube root of 405, you do it exactly the same way if we're guessing. It's between 7 and 8. So 7 and 8, which is, of course, 343 and 512. Now, when you're cubing, the numbers are really far apart, yes? Right? And they're not much like squaring. They're not nice, easy numbers to work with. So here's what I like to do. We're estimating, right? So is there a wrong answer? No. Emma, you can close that blind. Okay, but you will in like 5 minutes. The sun will move. Well, the earth will move, and the sun, that big rectangle of sunlight behind your head, will be on your head. But you can wait until it happens. Huh? You don't tan through glass, man. Regular glass blocks a bunch of the UVs. Regular glass. And I bet dollars to donuts that glass is low energy glass, which blocks even more UV rays to keep homes cool. So, well, no, you probably didn't know that. It makes sense. The sun is coming through. You would think you would still get a tan. You do, but it's much, much, much slower, even through regular glass, let alone through that. I would bet that glass is probably blocking 90% of the UV rays, if it's the kind of glass I think it is. I'm sure it is, because you put that glass in to help with heating and cooling costs. Anyway, so I got 405 in the middle here, right? Now what I like to do with this is I like to, because we're estimating, I like to change these numbers to numbers that are easy to work with in my head. So I'm going to make 343. I'm going to make 343 340. And I'm going to make 512 510. Why? Because now they're 170 apart, right? Easy to work with. 405 is 65 away from that, right? So 405 is 65 out of 170 steps, yes? Now that's pretty darn close. And I'm going to write the squiggly equal sign because it's not really equals. But that's pretty close to 60 out of 180, isn't it? Which is pretty close to what fraction? 1/3. So this answer must be pretty close to 7.33. 7 1/3, right? By the looks of how many people writing this down, I sense that a lot of people did not bother to do page 92 and 93, but that's okay. Everybody cool with that? And because it's an estimate, we're okay with doing that. If I go to my calculator, and I do the cube root of 405, indeed the answer I get is 7.4. And our guess was 7.33. Good enough to know you're on the right track in a big question, yes? So the next one, since you've now seen another way to do it, and since most of you probably didn't do F, do that one now while I take a sip of my coffee. It's still too hot. I poured it at 6:15 in the morning. It's the best travel mug ever if you like hot coffee. But if you don't like hot coffee, it's no good because I still can't drink my coffee. And it's been 2 hours. But my son gave it to me, so I can't tell him that. I should give that one to my wife because my wife likes super hot coffee. So what's 176 between? Right, it's between 5 and 6, so that's 125 and 216, right? It'll show up in a sec. I don't need to change 125, it's on a 5. I'm going to change 216 to what? 215. And 176, 175. So now, 125 to 215 is 90 steps, yes? 125 to 75 is 50 steps, yes? So it's 50 out of 90, which is pretty close to 5, well, is 5 out of 9, which is pretty darn close to 0.5, yes? So a pretty good guess for this would be 5.5. Of course, I'll check with my calculator because I like proving to you guys how much you can do in your head before you even do any math. Oops. 5.6. Our guess was 5.5. Pretty good, right? Okay, so I left you with, I expected this page done. All you had to do is follow the instructions. List the square root or cube root of each of the following. If the square root is rational. If it's not rational, all you did was write irrational. Did I ask for an estimate? So all you got to do is punch these into your calculator. I asked you to do that. A through H, I think, right? How many letters are on that page? Yes, the bell rang, but I have video of me saying you have to finish page 92 and 93. And it's written on the notes. Goes. Oh, yeah, no, I was questioning if the page goes to H because my computer's frozen. I don't know how long the page goes. Goes to R? R. No, it only goes to L. All right. So I asked you to do 12 calculations with your calculator. And from what I can see of the pages in my vision, I see a great many of them not done. 12 questions. I don't want to walk around because that's just going to make me feel worse about myself as a math teacher. So we're just going to pretend like everybody did it and the people that I can see that don't have it done wrote it in lemon juice. So if I held it up behind a candle, I'd be able to see it, right? Right. And see how I'm not saying your name, so it's not on the video. So if somebody checks, they don't know that you're the one getting in trouble. That's nice of me, hey? I know. So, all of these should be done already. They're not hard. Couple of them are, though, because you had to think. Because I never showed you, for example, that one, did I? But you guys are smart kids. So let's first do the ones that are easy. You punch that in your calculator, what do you get? 14. There's a negative out in front, so the answer has to be negative 14. If I were you, I'd be writing this down. When you punch 27 into your calculator, you don't even need to punch into your calculator because you've already memorized the perfect squares, yes? Is 25 a perfect square? Yes. What's the next perfect square? 36. Is that either 25 or 36? No, so chances are it's not a perfect square. So then you would check with your calculator and you would find indeed that it is irrational because your calculator screen fills up and it doesn't repeat. Now let's talk about C for a second. You guys are smart kids. That square root symbol, which is the radical sign, is covering what? Everything, isn't it? Right? If I gave you this, bracket, 3x squared, what's the base there? 3 and x, so they're both getting squared, right? Now, you guys should already have made the connection between squaring and square rooting, yes? So if that radical symbol is covering everything, what do you think that means? I never taught it to you. I wanted to see what would happen if I let you go. What do you think that means? It means, what was that, Jordan? Square root of everything. Square root of 9, square root of 100. What is the square root of 9? 3. What is the square root of 100? 10. So that's the right answer. Picking up what I'm putting down? Read my mail, mowing my lawn? Let's look at D. What does that square root mean? Everything. So it means the square root of 225 over the square root of 48. Either of those have a square root? Really? 225 does. That's 15 over, but does 48? No. So this one must be irrational. Picking up what I'm putting down? Okay. E is different because E is a decimal. Does it have a square root? It does. If you punch in your calculator, you find out that it is 0.5. If you calculate it. From your calculator, you get 0.5. But let's use our heads. 25 is really 25 over 100, yes? And if that's all square root, that's really the square root of 25 over the square root of 100, yes? Which is 5 over 10, which is 5/10, which is 0.5. Lots of people get F wrong. What's the square root? Now that you've seen a few of them, you should be able to do it in your head. 1 over 5. Is that rational? Sure it is. It's a fraction. What's the square root of 0? 0, because 0 times 0 is 0. What's the square root of 45? Can you do it? Nope. So it's irrational. What about the negative square root of 45? Still irrational. Doesn't matter, because I only asked you for an irrational number. 121? 11. Nice. And K. What do you know about K? You've already done 3 of them on this page. It shouldn't be that hard. Pardon? Is it irrational? A lot of people are saying it's irrational because a lot of people are saying it's 5 over root 20, right? What's root 5? Irrational. What's root 20? Irrational. So it has to be irrational, right? Right? Would you ever leave a fraction like that in Mrs. Bag Crumble's class? What's that really? That's really, I would go smaller. It's really 1/4, isn't it? So isn't this really the square root of 1/4? And doesn't that have a square root? What is it? Square root of 1 over square root of 4, which is 1/2. Please watch out for that. There's a reason we simplify fractions. Does 8 have a square root? No. So that's irrational. Let's turn over onto page 94. I want to do a little bit of work with this on a couple of different things, okay? We're going to be hopping all over this page, so please stay with me. First thing I want to talk about is making sure everyone can do one like that with just their calculator. Can everybody punch a cube root into into your calculator. If you have a backwards calculator, it's the same as square root, but you're going to hit the cube root button. Now, the cube root button looks like this. It's got a little 3 with the root symbol. Some of your calculators won't have that. But everybody look for that right now. It's often a second function key, like in trig. It's often written right on the calculator above the button. Everybody look around and see if you can see it. If you can't find it, have your neighbor look on your calculator to see if they can find it. If you do not have it, put your hand up so we can figure it out.
I think I know how to do it.
Oh, okay. Okay. If you don't have the little 3, look for one that has a little X with the root. You will have one of those two. If you have this one, it's automatic. You just push that button. If you have this one, you have to either push, if you have a forward calculator, you're going to push 3, that button, then 576. If you have a backwards calculator, you're going to push 576, that button, 3. And you might have to hit equals. That depends on your machine. Can everybody please make sure they can do that and have their calculator showing them 8.32? Can everybody get a cube root with their calculator? We talked about this in our very first unit when we were doing measurement, and I checked this then, but that doesn't mean anything. I have to make sure again. Everybody got 8.32? Everybody can use their calculator to find a cube root? Okay, now, if you have this button, but I ask you to find a 4th root, then you got to know how to use this button. You're going to have this button as well. Okay, so make sure if you have a cube root button and you were able to shortcut, that you know how to do it with the other button too. So go and try cube root of 576, but using this button instead. Make sure you can get 8.32. Is everybody good with that one? Yeah? Okay. So everybody can do that one. Great. Now I want everybody to go to C. We're going to skip B. We're going to go to C. All of you could punch that into your calculator, yes? And what do you get? Cubed root of 27,000. What do you get? 30, right? Okay. Now I want you to look at something. You guys are smart kids. Can I break that down to what? If I break that down to 27 times 1,000, and all that is under the cube root sign, what does that cube root sign over everything mean? It means the cube root of 27 times the cube root of 1,000, yes? What is the cube root of 27? You got a chart about it. I said memorize them. 3. What's the cube root of 1,000? 10. What's 3 times 10? 30. And you can do cube roots in your head if you can break them down. Everybody see how that one works? Okay. So that, I'm going to change color here. That one applies to what other, how far does this one go? Goes to R. On the screen right now, A through I, what letters does that method right here apply to well, do you think? Where could it help you? it might help you with E, might help you with F, might help you with I. Okay? Now, you guys are also smart kids. If something helps you 4 times in math, does it have the potential to help you in other cases? Yeah. That's what we're going to do today after we finish this page. Okay? So everybody work on 93 and 94. I think it's 93 and 94. No, I'm the worst kind of liar. 94 and 95. Get those 2 pages done in the next 10 minutes. And then we'll move on to use what you just learned, this method, to help you with every single square root. Okay? Oh, you're done? Cool then. I'll be putting up the right answers in a moment. Remember, go ahead and use your calculator as well. That's a skill too, but it's different than actually knowing the math you're doing. Okay? So for some of these, you're going to use your calculator. For some of them, I want you to try to do this, if it'll help you. Some of them, you won't need your calculator at all because you have the square and cube roots memorized, 1 to 20 and 1 to 10. Or if you don't have them memorized, you have them written down at least, because we wrote those down yesterday. 10 minutes should be more than enough time to finish these 2 pages. Course. You can talk to each other. It's not a test. You're welcome to discuss what you are doing here. I'm going to write out some answers up to I now. Oh, more zeros there than I read. The green is D through I. Check your work. Oh, maybe. I bet it is. Yeah, it is. Thanks, man. And there is down to R. You should be done to there by now. If you haven't, it's on the video. You can check your work later. $13.50. So everybody should be good with that. Are you? This is weird though, right? Because the volume is the same number as the surface area. But they are not the same, are they? Because one is squared and one is cubed. I gave you one just like that on your cumulative exam, where the volume and the surface area were the same number, just to see if I could mess anyone up. Is everybody good with the basics of roots? Now, what tool did we use mostly to do these questions? We mostly used our calculators, yes? And what is the problem with using your calculator? If it's not a perfect square, what do we get? A decimal. That is irrational, yes? Is an irrational number a number? Kinda. But can you find it on a number line? Does it exist? Why not? Because it's a decimal that doesn't end. So it doesn't actually exist anywhere, does it? The best thing we can do is round it off and get an approximate answer. Agreed? Math doesn't like approximate answers. Math likes answers. But sometimes those answers don't exist. And we've already had this example once. And the example that I'm going to give you before we move on to our next thing is this. Pi r squared. R equals 7. So that would be pi times 7 squared, which would be 49 pi, yes? That number doesn't exist, does it? Because pi goes on forever and ever and ever. So I told you when we were doing pi that from now on, we wouldn't write that approximate answer, would we? In our math classes now, we would leave it like that, because that is what we call an exact answer. Is everybody cool with that? So what we're going to learn now is how we deal with questions like this, the square root of 8. Because we know if we punch square root of 8 into our calculator, we're going to get a number like 2.7 blah, 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 right? Because the square root of 9 would be 3, and 8's just before that. Everybody cool with that? But we don't like this for two reasons. One, it's not exact. And two, just like this fraction, 25 over 45, that can be simplified, can't it? So can this. And that's what we're going to work on right now, okay? We're going to work on the way you're going to deal with square roots for the rest of your math career, okay? But before we do that, you guys have been working really well. Take a moment, shake your sillies out, talk to your friends, talk about your plans, talk about the fact that it's sunny today. I don't care. Take a moment, shake yourselves out, because I'm going to need your attention in a second. So use this time for yourselves. That means talk to each other, because I'm about to start talking to you, and you're all going to then start talking to each other. Use this time now. If you need a drink, go get one. If you're not going to talk to your neighbor, then turn the page over to Simplifying Radicals, and we'll be getting started in about a minute. You go, Jordan. All right. You already know how to do this. You did it last year. Yeah. Okay. Down to business. I'm going to be doing some highlighting on this page because, as always, there are the words, math words on here. And I, of course, use the math words. I don't have nicknames. I don't have stories very often. I use the math vocabulary because you're going to be expected to know the math vocabulary. So we'll open with the first one, a radical. A radical is any expression with this sign. Okay? We already talked about the little number that lives there. That's not part of what makes it a radical. That just tells you the kind of radical it is. this symbol needs to be there. Okay? Anything with that symbol is a radical. Okay? Now, radicals are broken down into two different categories. There is entire radical and there is mixed radical. Okay? An entire radical is this. Everything is under the radical sign. All right? A mixed radical looks like this. X, Y, Z. You've got something out front. Now, you guys are smart kids. You know what something out front does. What does something out in front do to the thing right after it? And I'll give you an example if you aren't sure of what I am speaking. What does this mean? 3Q. 3 times Q. So if it happens once in math, how often does it happen? Always. So what does this one mean? It means X times the square root of YZ. Is everybody cool with that? Who remembers the proper name for that number? It starts with a C. Yes, that is a coefficient. And we remember that coefficients multiply stuff. So the X here is a coefficient. So a mixed radical is a radical with a coefficient. Is everybody cool with the terminology? So I'm going to be using all three of those often today. Entire radical, mixed radical, and coefficient. Is everybody good with it? Okay, now, I would like for you to convert this to a mixed radical. So right now, it's an entire radical, yes? And it's a fairly decently sized number. Agreed? Okay. I want it to look like this. So that means I'm going to need a coefficient out in front, okay? Now, you guys have already seen something that will help you here. Okay? Two things that will help you here. One, when we had that really big number, 27,000, what did we do with it? What was that little trick I showed you? We broke it down into 27 and 1,000, yes? We broke it down into smaller numbers that we could work with. So let's break this down into smaller numbers. But the question you must ask yourself is, what smaller numbers do we use? Well, fortunately, I've given you the method to find those smaller numbers. How this works is we take the 72. Now, the 72 has a special name, just like everything in math. 72 is what we call the radicand. And that's yet another new word. The radicand is everything under the radical sign. So here's what we do. We take the radicand and we prime factor it. Prime factor it? Wait a minute, what are you talking about? That thing we did a few days ago? Yes. You take 72 and you make a factor tree. So everybody go. Because you don't need me for that part. What are two numbers I could put here? 8 and 9. Excellent. Are either of those prime numbers? No, so keep breaking it down. What's 3 break down into? What's 9 break down into? 3 and 3. Are those prime numbers? Yes. What does 8 break down into? 2 and 4. There's a prime number. And 4 breaks down into 2 and 2. Everybody cool with that? So now I am left with this. The square root of 72 must also equal the square root of 2 cubed times 3 squared. Does everyone agree? Everyone's cool with that, right? Because 2 cubed is 8, 3 squared is 9, 8 times 9 is 72. Is everyone okay? All right. Now remember, I told you there's a little number right there, yes? What's the number right there when we don't write the number? 2, because that's the smallest group of factors we can find, yes? So this question is looking for groups of 2. Is there a group of 2 2s there? Yes, there's actually a group of 3 2s, isn't there? So can I get a group of 2s out? Yes, because I'm looking for groups of 2. I can get out how many groups of 2? There's 3 2s in there. What's the largest group of 2 I can get out of there? I can get out 1 group of 2s, can't I? Right? So I'm going to go ahead and I'm going to remove that 2. Now it's out in front. Everybody cool with that? Did I remove all the 2s? No. I only removed 2 of them. So what did I leave under there? I left a 2. Can I get out a group of 3s? How many? 1 group of 3s. So out will come a 3. Did I take out all the 3s? There were 2 3s under there. I took them all out. Did I take out all the 3s? So there's no 3s under there, right? Now, I'm left with these 2 numbers out in front, which are coefficients. What do coefficients do? Multiply. So what do you think I do with the 2 and the 3? Multiply. To get what for an answer? 6 root, what did I leave under there? 2. And that is our grade 10 answer to root 72. It is not 8.5. Blah, 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 blah. Does everybody see? You don't have to be able to do it yet, because that's the first time most of you are seeing it. But by the end of this page, I expect you to be able to do it. Now, I'm going to give you some shortcuts along the way. But first, we're going to do a couple of these old school. So 99 is my radicand, yes? So the first thing I got to do is break it down. What are 2 factors of 99? 9 and 11. Is 11 a prime number? So we stop there. What does 9 break down into? 3 and 3. So what I really have is the square root of 3 squared times 11, yes? Is there a group of 2 there? How big? How many groups of 2 can I get out? 1. So what comes out here? 3. What did I leave under there? 11. And I'm done. Is everybody good? Okay. Let's look at 75. Let's break it down. What can I break it down into? 3 and 25. Is 3 prime? So I stop. 25? 5 and 5. Is there a group of 2 there? 3 times 5 squared. What comes out? 5. Not 5 squared, just 5, because I'm taking out the whole group. What stays under there? 3. Is everybody cool? Now, already you should notice there's a shortcut we can take here, yes? Look at this line right here, and look at this line right here. Isn't the square root of 99 also the square root of 9 times 11? Why can I put 9 there? Or why would I put 9 there? Because from our last page, didn't we learn that this is the same as the square root of 9 times the square root of 11? What is the square root of 9? 3 times the square root of 11. It doesn't have one, so it's 3 root 11. Does everybody see? Remember how I told you to memorize your square roots, perfect squares? If you know them, this gets a lot easier. because the root of 75 is just the root of 25 times 3, right? What's the square root of 25? 5. 3 doesn't have a square root, so it's 5 root 3. That's a pretty shaky 3. Do you have to know how the shortcut works? No, because you can always make a factor tree, yes? So let's look at 80. Can I factor tree it, or is there a shortcut I can use? If I know my times tables and I'm good with them, I could do a shortcut. I could do the shortcut in one step. Or I could factor tree. Or I could mix the two. So first thing I'm going to do is I'm going to factor tree 80. What would be there? What are any first two factors? 2 and 40. That's cool. 2 I'm going to stop at, yes? What would I break 40 down into? 2 and 20? No problem. 2 and 20. What would I break 20 down into? I'm going to just keep going, Josh, because you're going to say 2 and 10, yes? And then 2 and 5, yeah? So the square root of 80 is also the same as 2 to the 4th times 5, yes? Because I got 4 2's there, and I got 1 5. Does everybody see what we did? What size group of factors are we looking for? Groups of 2. Well, now how many 2's can I get out of there? 2. I can get out one group of 2 and a second group of 2, yes? And what did I leave under there? 5. What do I do with those numbers? Multiply. What's 2 times 2? 4 root 5. Everybody cool with that? Longest way you could do this, but always works. If you're happy with that, you can stop listening right now. If you want to know a quicker way to do it that will help you out when the questions get longer, pay attention right now. The middle of the roadway, 80, 4, and 20. I'm not going to break 4 down. Why? Because it's a perfect square already, isn't it? 20 breaks down into 4 and 5, right? So isn't the root of 80 also 4 squared times 5? Isn't it? Is there my group of 2? So what comes out front? The 4, and I left a root 5. Middle of the roadway. Every time you get to a perfect square in your factoring, you can stop. Right? Because you know the square root of 4 is 2. You know the square root of 4 is 2, so you can stop at perfect squares. Fastest way, you would recognize that the square root of 80 is 16 times 5, because I'm really good with my times tables. I can stop there because that's the square root, right? What's the square root of 16? 4. What did I leave under there? 5. Does everybody see how all three methods work? If you want to do this the quickest way possible, then you need to find the biggest perfect square that divides into your radicand. 300 is a big number, yes?
Yeah.
The factor tree would be very bushy, wouldn't it? Right? Can we shorten it down? What is 300? Isn't that 3 times 100? Does 100 have a square root? What is it? So what comes out? 10. And what stayed under there? 3. Does everybody see how all three of them work? Please notice they're all doing the exact same thing, aren't they? Except this one, I'm taking out the square root of that big number. And over here, I've broken it down as small as possible. I'm taking out the chunks in littler pieces. Does it matter which one you use? Not at all. So let's look at 63. Some of you are going to want to factor tree that. Some of you, hopefully, will do the trick I just taught you. Is there a perfect square that divides into 63? 9. That is 9 times 7, yes? What's the square root of 9? 3. So what comes out? 3. What stayed under there? 7. Is there a perfect square that works with 32? What is it? 4 times 8, right? Does 8 break down? What's 8? 4 times 4 times 2, isn't it? Is there a group of 2 there? What is it? So what comes out? 4. What stays under there? 2. Is everybody cool? You do 363. Go. You can factor tree and stop at perfect squares, or you can do the black, the red, or the blue with 363. I don't care which one you use. Which one do you think I will use, the black, red, or the blue? Knowing what you know about my knowledge of times tables, I'm going to use the blue one because that is 121, except I'm writing in black like an idiot. 121 times 3. Why can I stop there? Because 121 is a perfect square, right? What is it? 11. So what comes out? 11. What stayed under there? 3. Is everybody cool with this part? All right. Turn your page over. Now I'm reversing that. I have a coefficient here, yes? To get a coefficient out in front, it had to come out of the radicand, yes? If there is 1 2 out there, how many 2's had to be under there? 2 2's, right? So this is really the square root of 5 times 2 squared, which is what? 20. Everybody cool? Okay. So what would this one be? The square root of 29 times what? 7 squared, which would be 29 times 49, which you would have to do with your calculator because I can't do that in my head. Actually, I can, but it's going to take too long. So somebody with their calculator is going to know 29 times 49 for us. Great. Now, I want you to look at something because once again, does everybody understand the concept? If there's one of them out front, there had to be 2 of them in the radicand, yes? I want to show you a little shortcut. What number should be written right here that we didn't write? 2. What number should be written here that we didn't write? 2. Please notice that 2 squared went back under there. 7 squared went back under there. So what is going back under here? 6 squared, which is what? 36. So this is the square root of 144. 36 times 4 is 144. Now D is tricky. Why? There's a negative, right? So what number should be written here? 2. Does that 2 attach to the 5 or to the negative? Just to the 5. So this is negative root 12 times 5 what? Squared. 5 squared is 25. 12 times 25 is negative root 300. Does everybody see how that works? Okay. Now, I am going to shut up, and I'm going to ask you to do 3, 4, and 5, and I'm going to ask you to stop at number 98. Or page 98. But I want to call your attention to a couple of things. Notice in 3, what size of a group am I looking for? Group of 3, not 2. What am I looking for in letter C? A group of 4, not 3 or 2. Do you think any of my other methods change? No, I follow the same methods. Is everybody cool? All right, now listen to me. Yesterday after you guys left, I found out something. I can't be here tomorrow. So that's why I've written a quiz up there. Because I don't want to leave you with something new with the TOC. Okay? So here's what you're going to do. Right now, you're going to finish up to the end of page 98. Then, you're going to not do any homework tonight. You're going to look at all this stuff that we've been working on, and you're going to re-look back at your exponents. Tomorrow, you're going to write that quiz on exponents and this stuff. It's a quiz, so it's not going to hurt you, right? But this stuff is pretty easy concept, yeah? And then, tomorrow, you're going to work on, right now, you're working up to page 98. Tomorrow, I want you to work on page 100. You're going to write the quiz and work on page 100. Is everybody cool? Okay, and then on Thursday, we'll be back to new stuff. Okay? Everybody good? All right, you got 20 minutes now. Work on it. I lie. You've got 17 minutes now. Work on it.